Hey folks, welcome back to Reality Check. Now, since the 1970s, computers have been getting increasingly powerful, and as a result, gaming has progressed alongside, enabling fantastic advances like more complicated visual effects, bigger environments, and even exciting new ways of building entire game worlds. And today, we are here. The new current gen is the age of the PS4, Xbox One, Wii U, and the gaming PC. But where will we be in 10 years' time? Perhaps a new console generation, maybe some sort of PC console hybrid, or maybe your PlayStation will play you. Ugh, I really hope not. One thing we can guarantee though is that be it 10, 20, or even 30 years down the line, our computers will continue to get more powerful. Or will they? You see, the future of computer power is by no means a sure thing. Right now, in fact, top computer scientists from across the world are looking at entirely new ways of building these machines. And the king of potential, the holy grail, is something called quantum computing.
So the way we currently build computers, it's all about switches. Right, we use transistors, which are like tiny electronic switches in the computer, and the more powerful we want a computer to be, the more switches, the more transistors we try and cram on a chip. Problem is, there's only so small you can make these transistors before they become the size of an atom. Current estimates say that in less than 20 years, we'll be trying to get to that level, and then what happens then? So we need a whole new way of building a computer if we're going to try and get around this. Ultimately, we're going to have to face the fact we're going to have to deal with atoms inside our computers.
This is the basis of quantum computing. It's a whole new way of building a computer using quantum mechanics. Now, I know this sounds pretty complicated, but think of it this way. Quantum mechanics just explains the way very, very small things behave. You see, when you get down to the size and scale of atoms, the laws of physics that we all know and love from the large-scale world that we experience every day don't really work. When you get down to the size of atoms, weird and wonderful things can start to happen. It's almost like they can perform magic tricks, and this has huge implications for building a computer.
So once we get down to the level of switches in our computer being the size of atoms, we kind of have a problem, because atoms behave in such a weird way that they kind of misbehave. If you try and use a property of an atom for a switch, so maybe if the property is one way, your switch is on, if it's another way, it's off, it doesn't stay one or the other. So we have this inherent problem that atoms don't behave like a good switch. And it would seem that this behaviour that we call quantum mechanics is actually going to ruin our computer. But the key is to try and embrace that weirdness and use it to build a new kind of computer that is completely different from what we're used to, where the switches are these weird quantum switches.
Okay, so what exactly is this weirdness we're talking about? In what strange ways can very tiny things behave? Well, one example is superposition. So far, no one has really figured out exactly how or why this happens, but it essentially means an atom can exist in more than one place at once. I know, right? How on earth? I think I'll let Nicholas have a go at explaining this one.
Basically, suppose you take an atom, which can have different kind of properties. Let's say, for example, we'll talk about the colour of the atom. Atoms aren't really coloured, but it will do. It's just an example. And suppose you gave the atom one of two choices. The atom could move over here, and if it was there, it's going to get painted red, or if it went over here, it maybe ends up yellow. And suppose because it's so small, you don't really know which one's happened. It goes off, maybe it's got red, maybe it's got yellow, and then you bring it back to where you know it is, and you take a look at it. Well, what you'll actually find is that it doesn't end up red, and it doesn't end up yellow, it can end up orange, which is kind of weird because that would normally mean that it had to be both coloured yellow and red. It needed to know what was happening in more than one place, even though you never see it actually being in more than one place. And this is the trick of superposition. Some properties of atoms kind of behave as though they feel out more than one option. And this, it can seem like it would be a problem for making switches out of atoms. Is it on, is it off, is it what's going on? But it can be really useful.
Right, so that is kind of crazy. But let's accept that superposition is a thing. How then can we go about exploiting this to completely revolutionize computer power and therefore gaming as well.
So if you want to build a computer that really uses this quantum magic weirdness, then you have to throw away the idea that your switches are ever going to behave. And instead of using what we normally call a bit, like a 0 or 1, a switch on or off, we use what's called a qubit, a quantum bit. And in that situation, you just accept the fact it's going to be strange. And you have to completely rethink how you're going to program and build your computer so that this is your fundamental unit of computation, this weird behaviour. When you do that, things start to get amazing.
You know what? I think building a computer around these new weird quantum bits sounds really exciting. Currently, this technology, though, is still very much in its infancy, and while people have built quantum computers, they are very primitive and contain only a few of these quantum bits. But what if we allow ourselves to speculate? Say in 30 years' time we've made significant progress with quantum computing. What exactly might this look like? And also, what specifically could this mean for the future of gaming?
So if you ever do see quantum computers like on your desktop, because they're very good at certain specific problems, you'll likely see it as a kind of special chip, a quantum chip, that's surrounded by your normal computer and it gets called whenever you need to solve a certain kind of problem. So realistically, it's not going to be that you get like a quantum desktop. It will just be probably a small part of it. How a quantum chip could be useful for computer gaming is quite an interesting question, because we're still, relatively speaking, in very early days trying to understand exactly what a quantum computer can do. But there are some tasks it's better at that we could imagine would be useful. For example, it's very good at searching through long lists, and that is very much the back end of a lot of programming. Another very interesting area that's still being understood is that it turns out if you take two small things like atoms that have this quantum behaviour and you interact them and then move them far apart, they maintain a kind of a link that is much more powerful than we can actually explain. And this is called quantum entanglement. And that's, it's not clear at all what kind of benefits that could give, but it's got a lot of potential.
So, what do you make of quantum computing? Are you excited about its potential in the future? Let me know in the comments down below or by tweeting at me at CamFrazRob. Now, last week on Reality Check, I explored a second batch, a part 2 of PC graphics terms and what they actually mean. And then at the end of the show, I asked if you guys wanted a part 3. And it seems that you definitely do. So that is what I'm going to do next episode. Don't say I'm not good to you. See you next week.